Good morning, everybody. I see we are live. Let's give everybody else another minute or so to join, and then we'll start the webinar. Micrographics webinar, Autodesk software, evolving MEP industry using BIM for better design and fabrication. I see that the audio is good. Just a reminder that there is a delay on the audio, so if you have any questions, please, you're most welcome to use the chat. If you have any questions, then we'll respond to that on the live chat. Right, I think let's kick off. During this webinar, the agenda is as follows. We will be specifically looking at the evolving MEP industry using BIM for better design and fabrication. You can see that we've got the introduction, just a sort of a big picture. 40% of annual global emissions are attributed to the built environment. There's a lot more data on that and metrics. And then we want to have a look at some of the, sorry, I see that this slide is a bit, sorry about that. So we'll be moving on from that to look at the Revit, at the InfoWorks, the Revit, and the fabrication capabilities of the software. Firstly, the overall picture of what we're looking at over here can be sort of summarized in the following image. Looking at the design for sustainability and carbon analysis. So first of all, you'll see the typical sort of planning stages, the planning, design, build, and operate. And then we've got operational carbon and embodied carbon. So the difference between these two, operational carbon is when you are in an operational phase of the building, what is the energy usage? So if you can design a better building to use less energy, maybe with some passive heating and cooling, that is a good idea. And then also the types of components that you use, the type of heat pumps, whether you're using solar power generation, wind power generation, thermal power generation, as opposed to fossil fuels. That's the idea within the operational carbon. And then the embodied carbon, that is when you manufacture a building, the components that you are using or reusing, how does that fit into the scheme of things as well. And then we'll see over there that they mention below the embodied carbon the common environment for docs. And docs is essentially a common data environment. It's a platform where we are recording the BIM models and going from BIM to project information model, a PIM, and then into an asset information model called AIM, and ultimately into a digital twin, which is this, where this comes into the mix is in the platform called Tandem. So when it comes to Tandem, that is what we are looking at, the digital twin, and then what bolts onto Tandem later on during the operational phase of things. Of course, that's something else. But Tandem itself will be able to give us the ability to help us to optimize the operational phase of the building. And then we've got platform services. So these are services that third parties have created. Firstly, with Autodesk Forma. So for those of you unfamiliar with Autodesk Forma is a democratization of machine learning and artificial intelligence to help push the design of the initial building much earlier, so that we can get on with designing the building faster. It basically just pushes the curve of the cash flow and also the design much earlier in the project, allowing us to make important decisions at a low cost with a large impact. It does depend on everybody understanding their role and responsibility, but if we do that, we can even minimize the operational and embodied carbon during the project, because we'll make fewer mistakes and end up with a much better optimized model, because we are utilizing the machine learning and the artificial intelligence. And like we said, it's been democratized. In other words, it's user-friendly. You don't need to be a genius to operate that. Then it's built upon something that the older generation might remember as Green Building Studio. The GBXML export that you see, the GB stands for Green Building. And then Autodesk has transitioned into this Insight engine. Well, it's built, the Insight dashboard is built on top of the Green Building Studio engine. But that gives us a feedback on the carbon analysis and the energy analysis in our building. So we're looking at Revit for operational carbon. We're looking at systems analysis. And then for embodied carbon, you'll see that there are some add-ins there as well. Third-party apps, Tally, TallyCat, and OneClick. And then we've got Takeoff, EC3. Right, so Takeoff is quantification. So depends on how the project works out, but you could use Takeoff for quantification, in which case you can have the Takeoff, the analysis done in Takeoff directly. So just a note though, there's a lot of data for the United States of America and not so much for a place like South Africa, where we are operating from, or I am operating from. But we can always use the American data as a broad guideline. We must just always look at that with a critical eye and evaluate for ourselves whether the results are generally representative of our environment as well. Okay, so let's just have a look at Autodesk University for the moment, and specifically one thing that they deal with, which is design for sustainability and carbon analysis. So what is Autodesk University? Well, Autodesk University is a crucial source of information for those that want to know the current state of the industry and the future trends that might be that might put you in the lead regarding your designs. And it's held in Las Vegas every year. So if you're in Las Vegas or you travel there to go and attend in person, there will be a cost. But if you attend online, that's free. Typically in South Africa, it's presented in the evenings. You can gain access to the platform simply by navigating to the Autodesk University. Autodesk University page itself opens up as follows, and from here you would search, sign in first of all, and after you've signed in you can then search for the relevant classes that you might be interested in. Sign in there. Right, so this then shows us the Autodesk University is open for registration. So if you'd like to register for this year's Autodesk University conference, you can definitely do so free of charge if it's online. And then you can also search if you were interested in classes, if you were interested in something like MEP, like Revit MEP. Let's suppose you're just interested in Revit MEP. Then you'll see there's quite a few university classes. Now, the one that I'm specifically interested in is one that is called, we'll navigate it now. So there you can see there's quite a lot of classes for you to go and have a look at. Now, some of these might be relevant to you, some of them might not be. If you were in the MEP industry, I would definitely go and have a look at that to see what they're all about. So, unfortunately, I don't get enough time to attend all of them or to look at all of them, but this one specifically is a good one. Designing the Future: Insights into Carbon Analysis using Integrated BIM Sustainability Workflows. And generally you'll see a video presentation, which in this case it doesn't have, but there are 2 downloads that you can download, and I'll refer to them shortly. And that would be the architects. So we'll just quickly read about what this course is. It's the architects that are facing mounting pressure to meet sustainability targets from the onset of a project. The increasing recognition of our shared responsibility to the environment and its well-being is driving a shift. Like we said, 40%. Unlocking the collaboration amongst project stakeholders is critical in identifying decarbonization strategies using Insight for Revit software as a cloud-based platform. The hands-on lab session will explore through real case studies. Right. So basically these guys will then do a class. So there's not too much for you to see here. There's no video. But if you had to download those documents which are available, it's not under a safe harbor statement or anything like that. You can then get some good information as to the presentations. I can maybe just refer to that quickly. This is the document that was downloaded. Right, and well, there is a safe harbor statement, but it's still available for you to download, so it's fine. So that's where we got that image from. So the basic idea over here is that we've got from 2016 or 17, when I started getting interested in this, we used to have Autodesk Insight, and just before that Green Building Studio. 2019 we had systems analysis, and then into operational. 23 we went into Autodesk Insight with a tech preview, and now we've got the next generation that is being released in 2024. And it gives us, or at least in places where we've got data, we've got insight into the total carbon that's being used. Okay, and we're looking basically at the AEC data model for Insight, and then how it interfaces with Forma. Forma being the democratization of the AI and a general sort of shape modeling. And then with Revit, you can see that Forma, Revit and Insight interoperate like that. There's the detailed design, there's just the conceptual design in context, and that will then give you your optimized building solution or something that approaches that. The exercise files are no longer available. Okay, so 40% of the global emissions is due to the built environment. That's both embedded and operational carbon. And you can see that the total carbon with BIM, you've got the model, bill of materials, carbon coefficients. Okay, so materials with carbon dioxide factors is then attached from some other database onto the carbon coefficients of the materials, which then gives you your embodied carbon footprint. And this is where the third-party apps come in. Similarly with the operational carbon, we've got the building model, and then there's an annual energy simulation. We then get the energy factors, carbon coefficients, and into that energy simulation model we've got the carbon footprint. So both of them operate about the same way. It starts with a 3-dimensional model in the one end on the left hand side, which is just the actual building elements, the concrete, bricks, cement, and columns and beams and so on. And that has a cost associated with it. So, you know, if you, if I might give you an example, And this is just on the carbon side of things. We might look at something like a steel beam. So if you manufacture a steel beam in your own country and you purchase it from the supplier in your own country, then that steel beam would not have had to be shipped. So there is less carbon being used than if it was, say, shipped from a different country. And if the difference between the price of the shipped item is less than what your price is from your own country, then work in the difference with the carbon and then see if it's still the same price. Maybe you'll find that your own country steel is cheaper than the overseas steel. So that's one example. And then in the future, maybe we'll also have water, embedded water, and operational water, but also the manufacture of goods depend upon water usage. So clearly everybody is concerned with the environment, specifically with carbon emissions and with water usage, fresh water usage, and therefore these might play a large part in future with regards to our designs. Right, so let's just have a quick look at what you might expect from a course like that. If you attended this year, maybe they've got something there. But basically you get the model, then you get the energy model, there's the analytical model. You can analyze that model. You of course have to put the parameters in for the analytical model, and then you can view the analysis in Insight. Insight then opens up your dashboard and it tells you information about that. You can also customize that dashboard. And then there is the embodied carbon dashboard. So you can definitely see the different components color coded. Okay, so there's a lot of data that you can investigate your models, compare one against the other, and also benchmark that against the 2030 requirements that you might have. So to translate that for you, although it might not conform to South African green building standards or green star rating, whatever they call it, it's still a good guidance using an international standard for you to try and optimize your model based on another country's standard. Alright, so that's the nitty-gritty of the Insight dashboard. So that would be something on its own. The big idea to take away from this is that you're going to have the ability to create a design that is acceptable from a embedded energy, carbon, and operational usage. The handout itself, there is also another handout there. So in addition to the presentation, you'll see that they've got some information there. Most of these links are defunct by now. It's already a year later. The same picture that we've had before. But you can see that there's maybe a bit more information, a bit more data. The fact that the analytical energy model first goes into Green Building Studio and then into the Insight model. So Insight is based on Green Building Studio. I know back in the day I did a course through Autodesk with Green Building Studio, which was very interesting and pretty much gives you the same type of information than Insight. Insight's just more user-friendly. Right, so they do talk about a lot of the sort of Revit settings that you can do, what exactly it is that you are doing with the space types, the schedules, the operational schedule. You can see it's quite a long document, and you'll learn a lot from this document if you had to follow it from beginning to end. And again, this serves to help us to create the energy efficient design for our building. Okay, so do yourself a favor, register with Autodesk University and see if there's something new that you can learn from, something maybe an insight into the future where you might just gain the upper hand over one of your competitors maybe and come up with a better service. Right. Then looking at Forma, the the third-party app that they refer to, that would be C-Scale. So again, based on data from the States, right? So there you can see C-Scale is where you map the carbon factors onto the Autodesk models. They gather the data from the industry. Obviously, it's a service that C.Scale offers, and they understand the embedded carbon within building elements. And then over here, we've got Autodesk Forma, and based on that, you can see on the United States the potential for decarbonization, and then they've got the showcase client, Schneider Electric, and there's a few more. Right, so you can see it's definitely something that in the States the guys are thinking about it quite seriously. That's C-Scale, and that is available for Forma, obviously in an American context. Okay, there is some documentation of this as well. If anybody wants to have links to this in future, you're welcome to contact me. I'll provide that for you if you don't get that. There's Forma's embodied carbon analysis. There's a little video on that, which might be interesting to watch. I'll just switch the sound off quickly and get rid of the adverts. Sorry about that. Okay, so there's our quick presentation. You can see this is the Forma interface. There's the embodied carbon that's coming through that they then analyze. Just get to the actual. You can see how it looks like if you draw something in Forma. You can run the analysis, and then you can get some of the output depending on the situation of the buildings. There's the embodied carbon definitions and so on. Okay, and a different design would end up with a different embodied carbon results. So that would be your Forma embodied carbon. Got all of these Forma fundamentals. Again, it's a video that is released by Autodesk, and that is a series episode. There's the embodied carbon in episode 4. Right, so you'll see there's quite a few videos online where the guys are discussing this, how and where it fits into the general scheme of the analyses. Again, they show you modeling a building and then going into the design, the embodied carbon design. Okay, so that's something for you to at the beginning of the project, when it's still cheap and easy to make the decisions as to the construction, the conceptual design. Depending on the scope of the project, it might be quite a large project. You can see the evaluations between different designs. You can see the concrete versus steel versus timber. And there you can see a 69 versus 70 versus 62. Total embedded carbon 29,000 tons, 30,000 tons versus 18, so make it 19,000 tons. So definitely on the total embedded carbon, we're getting a much better result on timber construction, and with also a lower average carbon score. So that would be an example for you. In this specific situation, in this climate, in that position, in that city context, then it would be better for you to use the modern timber construction for the framing and so on. So there's an example view where it might be useful. That's Autodesk Forma's fundamentals. Then in Revit, again we've got the tally. This is for add-in, right? Tally is an Autodesk Revit application that allows architects and engineers to quantify the environmental impact of building materials for the whole building. So after we've done the conceptual analysis, we now want to map the carbon factors onto the elements, onto the data. So the 3D model elements now have the carbon data attached to them. And there's also BIMCAT. Okay, so the Building Information Climate Action Tool gives you a wholly functioning web-based carbon query database such as EC3 inside your Autodesk Revit project. You can upload material types and quantities to the web app from Revit and use a powerful estimation tool to get takeoffs in the units required by inventable product declarations. Evaluate the climate impact of savings opportunities over 100,000 verified EPDTs for your project. And again, this is done in America, in the American environment, but you could also sort of try and interpret that for your own country. There's some graphs that you can then look at, and you can also maybe generate the reports to buy clean policies for LEED and ICMS. So some of our clients, obviously, they do operate in America as well. But again, just using it as a guidance is not a bad idea to improve the environment. That's ultimately what it's about, is trying to minimize the impact of our buildings on the environment. So it's a good idea from a personal perspective. There's one click. It gets the same type of idea, get reliable whole building life cycle assessments. Deliver certification standards compliant LCA from your Revit models. The plugin works with structural and architectural models that can adapt to your material labeling practices. The plugin connects automatically. And so once again, there's something that is based on your evaluation of your building. There they show what that looks like. Okay, so those are the third-party apps that are available for Revit. And then on takeoff, there's EC3 for Autodesk. EC3 is not related to carbon accounting, beta features for takeoff. Okay. The embodied carbon and structure calculator integration is available for Autodesk Takeoff. EC3 integration for Takeoff allows you to import Autodesk Takeoff packages in Autodesk Construction Cloud directly into EC3 and export EC3 reports directly to Autodesk Docs. So it's once you've done your takeoff in the cloud, you can then write back a report from that takeoff into your project information model, or your building information model. Alright, so that's the last third-party app that we'll look at, I think. EC3 plus Autodesk Construction Cloud info sheet. So this information is available online. Again, until now, what we've done is to have a look at the overall structure of the design side of things. How do we design the conceptual model? How do we design the detailed model for carbon analysis, specifically referring to Insight. Insight is built on Green Building Studio, and evolving the model so that we can get from the conceptual to the detailed. Then we get to the reflecting the high-performing sustainable MEP system design in Revit. So I've discovered some wonderful video tutorials on this as well. So you'll find that it's a lot that's being done in a very short time. Can we just quickly have a look at some of them? There's the context. Let me just close some of these views so they don't take too much. This is the contextual model development. You can see it's a very short video. We'll just watch that without sound. I know that the sound is probably not going to come through on your side, but there you can see, I'll make it nice and big so you can see it. We've got the energy models within Revit with our zones and our spaces. The MEP guys might understand that. And then we'll be able to analyze that using Insight, the energy optimization, and clicking on those elements, we are placing spaces into those areas, and then we can then export that into the energy model and have a look at the data. I know it's going quite fast. It's just basically showing that you can place some spaces into the model. Obviously the spaces are bound by the building elements. You might be familiar with from the past, the building elements, and there you can see the analytical properties coming out. Again, within the optimization, there we are then looking at the analytical systems. What is it that we are supplying that for? And then we are getting information out from the rooms to see the power usage and the heating and cooling loads analysis that's required from that for the VAV system, for the heating and cooling, and getting a report out of that so that we can understand how much information. So now that's extremely fast, but it's the basic idea is clear. Then on the mechanical design and analysis in Revit, sorry about that, it's the wrong link. Come on, Paul. There we are. Alright, there's the create and review analytical spaces. This is a bit longer. Alright, so this just takes it through it a little bit slower, how to create the energy model for your building. You can see the building elements, the type of supplies that you do, the occupancy schedule, what type of spaces that you're working with. You can also define your own. We used to do this in the past. It's just a very more detailed, slower information about generating the heating cooling loads analysis. So I know with engineers sometimes they use external packages to do the HAPS calculations as well, but you can always read and write the information back into your model, but this, at least from a design side, will give you that ability to work with the Revit software. Okay, then we go on about electrical loads. I don't think we need to look at that right now. Obviously the electrical loads do play a part in general in MEP. We can maybe have a look at that quickly. But in essence, the less the power is for the systems that we use, the less electrical power we are using, and our mechanical equipment have connectors on them, and those connectors have the power usage, well, at least from design side. Of course, in future, or one would have to measure actually on the site itself, and then you can generate that. Okay, so it's just a typical sort of electrical design that we do. Essentially what we're doing is we're putting the loads onto circuit breakers on panel boards, and depending on the phasing that we are using, we want to calculate with the induction the power correction factors and the balancing of the phases, so that that's kept to a minimum. For those of you that do electrical, you'll understand. Then there's the MEP model analysis. There you can see this is a course again on Autodesk University, on Autodesk itself. That's training that you can do online if you're interested in. Again, everything we're showing at the moment, except for the third-party apps, of course, would be free. And we can see HVAC systems and sizing. Right. So again, typical sort of HVAC workflows. This is all within Revit. In general, if you know what you're doing, you can probably do this quickly. If you're a mechanical engineer, then that would be the types of things that you would be interested in. And this goes quite slowly and shows you how to do those energy analysis for the systems that you are using and get the information out of there so you can help design that building. Okay, and then once we have that, we are then set for the next step of our process. So the evolution so far, we would say that we've gone from the conceptual design phase, being able to impact the design of the project cheaply and with large impact, and now we've gone into the detailed design of our building. Then we get into the actual manufacturing side of things. So one of the things we didn't show here in detail is Autodesk Scan to Mesh for recap. It's something we've done in another webinar. In essence, the takeaway from doing reality capture, in other words, either total stations on site while you are manufacturing to manufacture accurately, or to reality capture what is manufactured to check against the design model to make sure that you fall within the specifications of your local authority regulations. There we would want to have capture the actual built asset. And these days with the Scan to Mesh, it's brilliant because you can clash detect in Navisworks as well. Compare existing or compare reality against the design model, and then some of the engineers in Captain have even said to me that when they got to the building, the floor was maybe 100 millimeters too low, and then that's 100 millimeters away from your head clearance ultimately, and so the entire HVAC system had to be redesigned at greater cost, and more expensive components had to be used. So that's what we want to steer clear of. So accuracy during manufacture is also important. That's where the total stations and the add-ins for Revit come in nicely. But then after that, and we've now designed our typical systems, we can then, and this is something that we've looked at here at Micrographics, or something that I normally just quickly teach within a MEP course, and that is, for the moment, we're just basically showing you a few quick videos with links just to make you understand the overall how do you say, the like large view on what it is that's available within the Autodesk portfolio. In essence, if you've got the water closets over there, then when you install the fabrication libraries, then you'll be able to select the fabrication configurations. So the idea is that you've got these generic components. For those of you who don't know Revit, you've got these generic sort of pipes, generic ducts with typical sizes, and then the fabrication parts, what they do is they interface with fabrication software, and this fabrication software can read the schedules that you're exporting from Revit, and based on the sizes on those schedules, on those components, they share a database, fabrication CAD MEP, and then you can actually spool them onto the devices. So it's not done so often with on a design side. It should be, as far as I'm concerned. You should actually be designing using real components ultimately, but it's also employed by the manufacturers themselves. So quite a common thing is for a Revit model to be sent to a manufacturer, and then the manufacturer will apply the fabrication parts onto the model elements within the Revit model and spool it onto these spools. So they offer it as a service, and that is then their competitive advantage. But it is quite a brilliant workflow. Not everything is possible, and so, sorry, I'm just trying to find my way around. There we go. Right, then you can convert fabrication design content into fabrication parts. It's the same thing, is it? Yeah. Sorry about that. Come on. Okay. You can route fabrication parts as well. Okay, so there's a routing tool. There you can see how they are selecting the fabrication parts to design with. You can design using fabrication parts as opposed to normal sort of Revit elements. There's choosing a PVC pipe, schedule 40. You can see there's a pipe part that you can create. There's where you can draw the pipe. You can draw the pipe. Okay, you can also choose the fabrication part in the type selector depending on what that is. There's the sizing. That's obviously in inches and feet and so on, imperial units. The demonstration that's available in metric if you choose the metric parts, and then you can see you can actually drawing in the PVC. Right, so the pipe segments are drawn, and then it will automatically connect them using the correct parts. Okay, so it looks a bit like a Revit pipe, but there are actual fabrication parts that can be sourced and manufactured. You can also optimize fabrication part links within Revit. Right, so this is about the optimization of parts, where you can select the fabrication parts. It's a simple click of a button, select the entire system there, and then you can filter out the ducting, and then just optimize the lengths. And there you can see that you've got most of them are similar lengths, and then it will divide it up, and then some of them will be a bit smaller. Okay, you can move it to the left and to the right. Okay, it's important that Revit makes it easy to optimize the straight lengths of a generic ductwork by adding or modifying lengths of straight segments. You can also just draw the optimized lengths from the start. So if you don't want custom parts, then just design using the standardized lengths. And that's quite a good idea. You can then create schedules. So it's a simple export as a MAJ file. That's the fabrication part. Basically, you're going to export this now. Well, you can put it onto a schedule. That's creating a schedule. It's not exporting it yet. Okay, Okay, so you can see you can get the fabrication ductwork schedule out. Obviously, from a cost perspective, this isn't so much on a carbon item, but of course, once you've scheduled this and you've got the third-party app, you can add the carbon factor onto this. Within Revit, if you typically how these things work is the apps create shared instance parameters which you attach to elements, which are then updated using the carbon database, which is recorded over time and released to the industry as the industry evolves. So this is what you're seeing at the moment. They're adding parameters, while the carbon parameters would also be added to them, and that'll be available for your reporting. So you would get a report out as to your ducting is going to have so much embedded carbon. So that's the reason why our schedules would be important for us. Of course, the app might just simply pull it out automatically. And then lastly, you can tag elements and create some sheets. So that's trivial. Then we get to scenario planning. I think this is also important to understand in the overall scheme of things. When should you do what and use what? All right, so on a typical architectural building, we would say use Revit for plumbing, ducting and piping. Then use reality capture to scan to mesh and for as-builts. Then you can always clash detect them, like we mentioned. You want to have a record of what the building actually looks like as opposed to the design. And then use Revit for creating fabrication parts. That's what we've just looked at. To install the Autodesk fabrication MEP metric content from your account if you want. So that's actually, if you have the AEC collection, then you could have a look at your Autodesk account, and in your Autodesk account you'll see on the AEC side, or you can ask us if you don't have access to this, but there should be a fabrication CAD map in your AEC collection. So in Revit, it's interesting, in Revit you've got the general catalogs. So if you look at your Revit, where's Revit? Revit. There's Revit. Okay, so if you look at the view details in Revit, then you'll see your extensions. Then you should find that there's an MEP content editor sync content catalog 2022 to 2026. So some of these add-ins, they are relevant to the fabrication parts that you've got available to you. Specifically, if you look at fabrication CAD MEP details, there is an interesting library download for you, fabrication CAD MEP metric content 8.02. So if you install that, it's going to be available for you in Revit as well. That's the idea there. All right, and you can export also to a MAJ job file. So that's if you use just the standard fabrication parts. You'll see it's something like this. All right, you can just export it in Revit to an export job file. That means that the manufacturers will be able to manufacture that. And then you can also manufacture using fabrication CAD MEP. Okay, so this is quite a long video. I'll just skip through it a bit. You can take Revit content into fabrication CAD MEP. Right, so that's basically your Revit. If you open that, you can filter out the elements, and this shows you that you can export these elements into fabrication CAD MEP. That's just the MAJ export, and you can then bring that into fabrication CAD MEP. Okay, so that's on the manufacturing side. There you can see the elements now created in fabrication CAD MEP. So of course, on the manufacturing side, they've also got the MEP software that will help them to quantify and cost the components. Then what about an architectural model where there's non-typical fabrication parts? Well, the first bits are the same, but then we've got to map inline model elements to fabrication parts. There we go. Alright, so it's basically a method for you to use, again, an add-in to take the non-trivial inline elements as well as models that might have been created and to send them to a fabrication model. So basically you'll select the elements that you want to export. Come on. It's not really showing me what I want. Okay, but that's the methodology anyway. Then I've just mentioned something here, which is something we learned recently from mining companies who have used Revit for piping. There's a workflow where you go from, or supposed workflow where you go from Revit to fabrication parts to plant 3D. The reason being that they would like to have ISO drawings. And we discovered that it isn't trivial to go from Revit to fabrication parts and then to plant 3D for isometric. So if you are going to be modeling those types of models, don't use Revit. You know, if your petrochemicals or your plants, don't use Revit. Typical architectural building with, if you're a fabricator and you're going to be building that or modeling that from scratch, if you're the person designing it, if you know what you're doing, then, well, if you don't need to do analytical designs or anything like that, then you can just manufacture directly using AutoCAD MEP and CAD MEP. So that's, of course, part of the AutoCAD toolset. I wouldn't use AutoCAD MEP in a Revit model for a Revit design, but I would use it if I was a manufacturer and a manufacturer only. So you need AutoCAD to run fabrication CAD MEP. And if you have an AutoCAD license, then you've also got AutoCAD MEP. However, if you were in the design team on the HVAC side, on a typical project, they would require you to use Revit. So even though you've got AutoCAD MEP, you can definitely go with fabrication CAD MEP. A typical industrial asset requiring isometrics. This, you shouldn't consider Revit whatsoever. You should start off with Plant 3D and just design immediately in Plant 3D. Then you can take the PCF to ISO for manufacturing. That's basically something that we do in Revit as well. Okay. So that's Plant 3D. So if you're doing mining, if you are doing petrochemicals or food processing plants, that type of thing, go with Plant 3D from the very beginning. If you're in manufacturing and you are using Inventor for piping and for equipment manufacturing with connections on them, well, there's going to be two interesting workflows. The one is from Inventor to Plant 3D, and you can use a PCF file to the pipe function within Plant 3D to convert that, and you can also convert some equipment with connections. So there's two links over there, and I'll just quickly show you what that looks like. It's just a help. It's one of the forums. How do you convert the PCF to pipe? So that conversion is possible. We've got the equipment with connections as well. If you want to get the equipment into Plant 3D, so if you're a manufacturer and you need that content available within Plant 3D, that's also possible. And then of course there's the Inventor to Revit workflow, where we can, the Inventor to Revit interoperability. Basically, if you are going to be designing the component within Inventor and you want to use that within your Revit environment, you can do so. So with that, I know that there's not a lot of time left, but do want to open it up for questions. If anybody does have a question, you're welcome to ask. I don't see anything coming through on the live chat, so with that, there's some just remember Autodesk University. We do also have a YouTube channel. There is a webinar series for you to consider as well, and then also our blogs, which you can peruse. You might find some interesting information that might be applicable to your workflow. I thank you for your time, and hopefully this has given you a broad overview, a high-level overview of the way in which the MEP industry is adapting in the Autodesk ecospace. Until next time, enjoy BIM.